Okay, so this is a brief set of notes on separable ordinary differential equations. And essentially, a separable ODE is any ordinary differential equation in the form of dy dx is some function of x times some function with respect to y. So the key here is that this has to be multiplication between the two. Why they're called separable is because you can separate the y's to one side of the equation, the x's easily to the other side, and then integrate both sides to solve. So let's take an example. Okay, so an ordinary differential equation initial value problem for a separable ordinary differential equation could be something like dy dx is equal to 4x over y, where the initial value is that when x is 0, y is 5. Okay, so this is clearly a product of a function of x and a function of y. The f function would be 4x, so f of x would be 4x, g of y would be 1 over y. And if I multiply these two together, I get 4x over y. So we manipulate this so that we get the y on one side and the x on the other, with the y differential and the x differential. And once I have this, I can integrate both sides. So this is going to give me 1/2 y squared. This is going to give me 2x squared plus some constant. Now note, not every solution to an ordinary differential equation is going to be a function, and this in and of itself cannot be written as a function. But we can find the value of z given the initial data. So when x is equal to 5, right? When x is equal to 0, y is equal to 5, right? So this equation should reduce to 25 over 2 is equal to c. So I can rewrite this equation without the c as 1/2 y squared is equal to 2x squared plus 25 over 2. And if you use implicit differentiation on this, you will get back that derivative. And you can plug in the 0 and the 5 and see that this crosses through that initial value. So this is the solution to this ordinary differential equation. So let's look at a second example. Okay, so let's take the ODE dy over dx is 3x squared y. So that's clearly a product of a function of x and a function of y. And we're going to say that when x is equal to 0, y is equal to 2. All right, so we separate. We get 1 over y dy is equal to 3x squared dx. And when separated, we take the indefinite integral. So this is the natural log of the absolute value of y is equal to x cubed, right? And then I have to have some constant. Okay, so when y is 2, x is 0, so the constant here is the natural log of 2. So we get the solution that the natural log of the absolute value of y is equal to x cubed plus the natural log of 2. And this would be a solution to this ordinary differential equation at that initial value. And there it is. So if ordinary differential equations are separable, they can be solved by integration. Boom.